Hello, everyone. My name is Sai, and I'm going to be presenting question 4 from the quiz. Question 4 talks about non-conducting sphere, which is the same thing as an insulating sphere. We already know that insulating spheres have a charge inside that it's evenly distributed throughout the volume, right? So knowing that and what's given on the question, we know that inside and outside of the sphere, we're going to have different electric fields, right? So in order to solve the problem and in order to organize the info that we have, we can draw different Gaussian surfaces based on what's given in the question. So for example, here I did a Gaussian surface with radius r divided by 4, and then I did the 2r Gaussian surface outside of the sphere. So drawing the Gaussian surfaces, we can use the equation E times A, the electric field, times the area, which is going to be equals to the charge inside divided by the constant. And if we already know that any electrical field inside of an area of an insulating sphere is given by the equation KQ times R divided by the R, the biggest R, which is the sphere, then we can solve for the 2r distance of the sphere outside of the sphere, right? So given this equation, we already have the electrical field, we have the ratio between the radii, and then we have the constant and Q being the charge of the non-conducting sphere, right? So to solve for the electrical field 2r, then we can also make the relationship that K times Q divided by 2r squared would be the electrical field for that distance. Now we have to put it in terms of E naught, of what's given. So if we do that, we get, let me solve this. So this will end up being 4r squared, right? And then we ended up getting that E naught, if we substitute the radius, the smallest radius, which is r divided by 4 squared, r divided by 4, I mean, divided by r to the third, then we would get that. All right. So by doing that and putting the ratios, we get that E to R will be equals to AQ divided by 4r squared AQ r squared, and then the 4, because we're taking it out. Once we find that, we see that everything cancels out, and we get that E to R divided by EO is equals to 1. So the electric field at 2R will be equals to E naught, or the electrical field inside.